Okay, so 2c, cosine of 2x plus sine of x equals 0. For this one, we're going to substitute in for cosine of 2x. That's obviously a hint to use a double angle identity. And in this case, we want to replace it with something with sine in it because we already have sine in the equation. So that would be 1 minus 2 sine squared theta. Once you replace that, you can kind of see that it's going to become a quadratic again. So let's rearrange it so that it's in the order of descending powers. So we're going to put negative 2 sine squared first, then we're going to put sine x next, and then we'll put plus 1 at the end. Now, if we replace the sine theta with t's, then we'll have negative 2t squared plus t plus 1, and now it's obviously a quadratic. You can factor that, put 2t and t for the first terms and 1 for the second terms, and then you just play with the negative signs until you get the exact right combination. So it would be positive 2t and negative t, and then if you can see that that combination works out, you multiply these two together, you get negative t. You multiply these two together, you get 2t. 2t minus t is t, which is the middle term, which works out, okay? So the left side, if you set that equal to 0, you're going to get 2t equals negative 1, right? Now I did 2 algebra steps in one, and you can see where that got me. I made a mistake. So t is equal to negative 1/2, so the sine of theta is equal to negative 1/2. What are the solutions for theta for negative 1/2? That would be like this angle and this angle, where this is negative 1 and this is 2, negative 1, 2. So that would be, let's see, that one would be pi plus pi over 6, which would be 7/6 pi. So one of them would be 7/6 pi, and the other one would be 11/6 pi. This one here. Okay? So those would be two solutions for this side of the equation. Now for this one, it says negative t plus 1, so we solve for t, we get t equals 1. So, and t is equal to sine of theta, so sine of theta equals 1. When does sine of theta equal 1? Well, it only equals 1 at pi over 2. Okay, so we have three solutions for theta in between 0 and 2 pi. Moving on to the last one, e. Sine of x plus cosine of x equals the square root of 2. This is a pretty tricky one. You can't directly substitute anything in here to make the sines into cosines. You have to square both sides. And if you square both sides, then you're going to get an expression with only a sine or only a cosine, and then it makes it possible to solve it without a calculator. So you end up with doing FOIL, and you get sine squared plus 2 sine cosine plus cosine squared. So the first term is going to be sine squared, the last term is going to be cosine squared, and the middle term is going to be 2 sine cosine. Then we can take the sine squared and the cosine squared. If we add them together, we get 1, and the sines and cosines disappear. Then 2 sine of cosine is going to be using the double angle identity. It's sine of 2x, right? So we have 1 plus the sine of 2x equals 2. We combine the 1 and the 2, we subtract 1 from both sides, and we get sine of 2x equals 1. So 2x is going to be either equal to pi over 2 or 5/2 pi. Those are the two angles which give us a sine of 1 between 0 and 4 pi. And why are we doing 0 and 4 pi instead of 0 and 2 pi? Because originally we're looking for an x between 0 and 2 pi. Well, since we're working with 2x, then we're looking for an answer between 0 and 4 pi. And then we're going to take half of that to get the x, right? So now let's take a half of that and to get the x. And we get an x of pi over 4 and an x of 5/4 pi. Those two solutions, when multiplied by 2 and 2x, are going to give us a sine of 2x equals 1. Now, one thing that we need to go back and do is we took a squared here at the very beginning, right? And when you square it, that's fine, they're both still equal, But you need to check all your solutions to see if if they still work with the original equation. Because when you, like, let's take -2 equals 2. Let's square both sides. It now equals 4, right? So it looks like it's equal, but the original equation, -2 equals 2, was not equal, right? One was negative, one was positive, but when you square it, you lose that. So what we need to do is we need to check our solutions with the original equation and make sure they actually work, even if we don't square it, because the original equation is not squared. So we take sine of pi over 4, and we add it to cosine of pi over 4, and we see what we get. Well, sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. So we add them together and we get square root of 2. So that is exactly the original equation, right? I'm going to erase the squares so you don't get confused. Now, so the pi over 4 solution does work. What about 5/4 pi? Sine of 5 pi over 4 plus the cosine of 5 pi over 4. What does that equal to? Well, remember, 5 pi over 4 is this angle here. The sine of this angle would be -1 over square root of 2. The cosine of this angle would be -1 over square root of 2. So you're actually, and we could also say it's square root of 2 over 2. So negative square root of 2 over 2 minus square root of 2 over 2. And that gives us negative square root of 2. It didn't give us positive square root of 2. It gave us negative square root of 2. So the 5/4 pi is not a real solution because it's not a correct solution because it only appeared because we squared both sides. When we don't square both sides, it's not a valid solution. So 5/4 pi is not a solution. We're leaving only pi over 4.